Alrighty, hello and welcome back to Mr. Pog Talks About Math and Stuff. Today we're going to talk about the point-slope form of a line, right? So what we're going to hopefully be able to do is write and graph these types of equations in point-slope form. So we're going to start off with just a little thing where we're going to graph some lines, right? Just to warm up a bit. We're going to graph a line through the point -3, 1 with a slope of 1/4. So the first thing we're going to do is we're going to plot the point -3, 1. Right? So on our graph over here, that little red dot I just popped on there. Right? After that, what we want to do is we want to use rise over run to find a second point. Right? So when our slope is 1/4, right, and I'm thinking about rise over run, the rise is on top, that's the 1. The run is on the bottom, that's the 4. Right? 1/4 means that I'm going to rise 1 from that original point and then run 4. Right? So I'm going to zoom in on the graph real quick just to make it real clear. So rise 1, run 1, 2, 3, 4 over to get that second point there. Right? So we've got 2 points on our graph. Right? Now what we're going to do is we're going to connect the points. Right? We're going to have our line go edge to edge on the graph, and then we're going to put arrows on the ends. Right? So I'm going to try using a ruler on top of this thing, which might go a little iffy. Right? Not too bad. Right, so my line goes from edge to edge. I'm going to throw some arrows on the ends. Whoops. Switch to that. Right, there we go. That's the line. And that's pretty much how we're going to graph these point-slope form equations, right? There's a little bit more work in the front end of it to figure out what the point and the slope are, but essentially the process is going to be the same. Let's try it again with this one. We're going to graph a line through the point -3, -2 with a slope of 2. Right, so again, our first step is that we are going to plot the point -3, -2. And then after that, we are going to use our slope and rise over run. So the tricky thing about this slope is that our slope is just 2, right? So remember that 2 and 2 divided by 1 are the same thing, right? So when I have a slope of 2, I can talk about it as 2 over 1. That gives me both a rise and a run to work with. All right, so again, I'm going to kind of zoom in a little bit as much as I can to keep everything on at the same time. I'm going to plot -3, -2 right down there. I'm going to rise 2 and run 1 to get a second point right there in blue. And then I'm just going to connect the points. Right, I'm going to use a ruler. Hopefully we're going to get a nice straight line here. Not too bad. Right, and if you're doing these freehand, right, if you don't have a ruler or a straight edge of some kind, it's not the end of the world, right? Try and make it as good as you can, but it doesn't have to be a work of art, right? So, again, this is the process we're basically going to be using. Let's talk about the actual point-slope form of a line. So this is going to be real important. So if you're like kind of zoning out a little bit and maybe not writing everything, make sure to write this down. So the point-slope form of a line looks like this. It's y minus y1, then we got an equal sign. On the other side, then we have m, and then some parentheses with x minus x1 inside. All right, so there's a couple different things going on here, right? Anything that's in red, right, the x1 and the y1, right, is the point. Right, we've used x1 and y1. We were talking about slope a little bit ago. Right, so those are things that we fill in based on what the point is. The m is our slope. Right? Anything that's in black, right? So the y, the x, the minus signs, the parentheses, the equal sign, all of that stays as it is, right? So I guess we could say, don't fill in anything that I have written here in black. Right? We want to fill in the stuff in red and the stuff in blue, right? So when do we want to use this, right? Well, it's pretty easy, right? The first thing is, as the name implies, we want to use point slope when we have a point and a slope, right? That's really all it is. The other situation is when we have 2 points, right? When we have 2 points, we can then calculate the slope, right? We've worked with the slope formula already, and then we'll have a point and a slope that we can use, right? So again, make sure that you have that point-slope form of a line written down, right? And we're going to take a look at actually writing some equations together. So on this next page, it's a whole bunch of times where we're going to be writing out point slope form equations. Up at the top of here, I'm just going to write it out real quick, right? This is like the skeleton for it. And we got m and then x minus x1 in parentheses. All right, so we want to create the equation of a line with a slope of 4 that goes through the point -1, -6. All right, so you might notice I just underlined two things in two different colors. The slope, I'm going to plug in right where the slope goes. The point, I'm going to plug in where the point goes. And we're going to take it one step at a time, right? Because there's something a little tricky about these. You notice that I have my formula right up there. What we're going to do is I'm going to start off with just the skeleton of it when we're writing it out together. All right, so all I did was I kind of cut out the x1, the y1, and the m, and I left everything else. All right, so I would call this the skeleton of this point slope form. What we're going to do from here is we're just going to drop the numbers on in, right? My slope is 4, right? So what I know I'm going to need to do is I'm going to plug a 4 in right where m was, right? Slope goes there. Right? If it helps, you can put little reminders over these, right? That's m. This will be, x1 and y1 over there. All right. So the reason that I'm having to start with the skeleton of it is because this next part can get a little tricky. We have y minus y1. Well, y1, if I look way over here, is -6. Right? So when I plug in y1, I want to plug in -6. Okay? When I plug in x1, right? x1 is -1. I'm going to plug in -1. Right? So you might notice that I have these two areas where I have double negatives going on, right? That's intentional. Those subtraction signs in black are built into the formula, right? We don't want to forget those, right? Especially when, in this case, we plug in things that have more negatives. When you've got a situation like that, what I would suggest is we're just going to simplify those double negatives to be plus signs. So that turns into y plus 6 over there, and then x plus 1 in the parentheses over on the other side. Right? So when you look at a point slope form equation, sometimes it can be lying to you just a little bit, right? Subtraction actually means that the number we plugged in was positive, right? Because the subtraction is built in. And if it looks like addition, like it does here and over here, the number we plugged in was actually negative all along, right? It's a little bit tricky. We're going to keep on working on it. All right, let's try another one out. So actually pause here, try the next one out on your own, see if you got it. So hopefully you did that, right? Same idea, right? We have a slope of -3, so that's my m. I've got a 4 and a 5 as my x1 and y1. And all we're going to do is we're going to plug them in. So I'm going to start with the skeleton. Right, again, leaving all those blank spaces where we're going to plug numbers in. My m is -3, so pop that in there. My x1 is 4, and my y1 is 5. Right? On this one, I didn't have any double negatives, right? So I don't have to worry about it, right? You might be tempted to go ahead and distribute that -3 and kind of move things along so that the parentheses aren't there. But for what we're doing right now, we don't need to worry about it, right? We're all set. That's the answer. Y minus 5 equals -3, and then x minus 4 in parentheses. Right? Sometimes they can get a little trickier for different reasons, right? This one's talking about a slope of -5, right? No problem there. And then an x-intercept of 22, right? So I'm just going to do a quick little sketch here, right? If we have an x-intercept of 22, right? Let's say the 22 is way over here on the x-axis, right? What that's telling me is that, my line might look something like this, right? But what we're focused on is the fact that the x-intercept is over at 22. So you got to think about what are the coordinates of that point, right? We need coordinates for the point in order to plug it in. So it has an x value of 22, and then it hasn't gone up or down at all, so it's at 0. So my point for when we have an x-intercept of 22 is just 22, 0. That gives me an x1 and a y1, right? After that, we're going to set up our skeleton, right? I'm just going to plug everything in, right? Our slope in the middle is -5. Our x1 is 22, and our y1 is 0, right? When you have a situation like this, It's definitely okay to simplify, right? Y minus 0 is just y. Right, so we could simplify the whole thing down to look just like I'm writing here. Right? Is it going to be wrong if you don't do that? No, of course not, right? I wouldn't mark that wrong if you left it with the minus 0, because these are the exact same thing, right? We should try to get in the habit of cleaning it up and having it look like the second one, but it's not the end of the world if we don't. All right. For number 6, same kind of idea, except now it's talking about a y-intercept. Right, so again, I'm going to kind of do out a quick little sketch here. Right, let's say that my graph looked something like this. Right, and I'm not doing a good job of putting arrows on the ends. Oh, man. Right, if I have a y-intercept of 4, a y-intercept is on the y-axis. If I'm trying to, talk about that point is at 0 for x, right? It hasn't gone left or right at all. And then it's up 4. Right, so that gives me an x1 and a y1 that I can use. As for the slope, it tells us that it's 1/4 right in the middle of that problem there. And then we just throw everything in, right? Set up our skeleton, y minus, we got an equal sign, and then x minus. Right? So again, it's y minus y1, which is 4, equals m, the slope, which is 1/4, and then x minus x1, which was 0 here, right? And again, this is another situation where we could simplify a little bit if we wanted to. It's not the end of the world if you do or don't. Right, but if we did that, right, x minus 0 is just x, and then we don't need the parentheses anymore. That's what we could get to from this. Okay. So hopefully this doesn't seem super duper bad, right? We're just like plugging these different things into this basic formula right up at the top here, right? Y minus y1 equals m, and then x minus x1 in parentheses, right? Especially while we're still getting pretty good at these, it's not a bad idea to just like write this at the top of each page that you're working on, right? So you don't have to keep flipping back or be like, oh man, what order did it go in? Stuff like that. So we got a couple problems down here. What I'm thinking is we will do a couple of these together. We might save one to just be exclusive to the notes that I'll upload, right? So here we're given 2 points, right? We don't know the slope quite yet, right? We have 2 points to choose from, though. So what I'm going to do is I'm just going to label these points, right? Let's call this one x1, y1. We'll call the other one x2, y2, right? So our very first step is that we are going to have to find the slope, right? So first, find the slope. Right, so remember that our slope formula looks something like this. We've got m equals, right? It's got y2 minus y1 up on the top and x2 minus x1 down on the bottom. All right, so our slope formula looks like that. We already have an x1, a y1, an x2, and a y2. So all I'm going to do is I'm going to plug those numbers right on in. All right, so I've got my skeleton set up. It's y2 minus y1 up on the top. It's x2 minus x1 down on the bottom. All right, so the reason that I like doing the skeleton, and I'll zoom in a little bit so it's a little bit easier to talk about. The reason I like doing the skeleton is because, again, we've got a situation where that's 20 minus negative 4. That's supposed to be that way, right? We would then want to simplify that to be 20 plus 4. Right? So 20 plus 4 is 24. 18 minus 10 is 8. Right? And if I do 24 divided by 8, oops, first off, we could just erase the whole thing, right? But 24 divided by 8 equals 3. Right? So my slope is just 3. Okay, so after that, we know what our slope is. We don't really even need that part on the screen anymore. Now what I can do is I can set up my point slope equation. Right? It's y minus y1 equals m, and then x minus x1 in the parentheses. All right, and again, y minus negative 4, let's turn that into one big plus sign there. So you might be asking yourself, what if I wanted to use the other point, the x2 and the y2? Perfectly fine, right? You don't have to be tied to just whichever one you labeled x1, y1 when you do this, right? If I was, starting this problem over, maybe, I did these in reverse order. Maybe I called this one x2, y2, this one x1, y1, right? Obviously, we didn't do that, but if we had, it would still be okay. So another way that you could write your point slope form equation is y minus, in this case, the y2, which was 20, equals that slope of 3, and then x minus the x2, which is 18. Right? So they might look a little bit different from each other, but these are actually talking about the exact same line. Right? So you can use either one. Right? There's no big deal either way. Choose whichever point seems better to you. Right? Let's try another one out. So number 8. Right? Again, we got two different points. I'm going to label them x1, y1 and x2, y2. x1, y1, x2, whoops, that's not what I meant to do. x2, y2. If I can get the eraser to cooperate, there we go. All right, so again, we're going to start off by finding our slope. So we're going to have that m is equal to, we got y2 minus y1 on the top. So in this case, that's 4 minus negative 2. And x2 minus x1 on the bottom. Negative 5 minus 7. Okay, so I'm going to kind of zoom in a little bit. Up on the top, we now have 4 plus 2, right? So 4 plus 2 is 6. On the bottom, negative 5 minus 7 more brings us to negative 12. Right? So 6 divided by negative 12. So you might be weirded out a little bit, right? You don't often see a negative sign just hanging out on the bottom of a fraction. Well, let me tell you something, right? 6 divided by negative 12 is the same thing as negative 6 over positive 12. And it's the exact same thing as negative 6 over 12, just like that. All three of those mean the same thing, right? But the long and short of what we're going to do is we're going to simplify that. Right? We can simplify that to be negative 1/2. Right, so that is our slope that we're going to work with. So again, two different ways we could write this out, right? Maybe pause here, see if you can write at least one of them out, and then unpause when you think you got it. So hopefully you did that. I'm going to write out both, right? This is y minus y1 equals m. And then we've got x minus x1 in the parentheses. All right. And again, we can turn that y minus negative 2 into y plus 2 there. The other one would look like this, right? Y minus the y2 equals m. And then x minus the x2. And again, on this one, in the parentheses, x minus negative 5 can turn into x plus 5 there. Okay. So I don't want this video to be super duper long. What I'm going to do is I would encourage you to try number 9 when I upload these notes to our Google Classroom folder. Right, they will be filled in and all done out. Right, but I want to make sure we keep on going so you don't have to listen to me for too long. All right, so now as far as the graphing goes, it's not going to be too bad. Right, our very first step is to find x1, y1 and plot the point. Right, then we're going to find the slope and do rise over run to plot a second point. And then connect the points, right? So again, it's pretty similar to what we did right off the bat on those first couple examples together, right? Except now we're going to be getting the information in the form of the equation, right? So that first step is honestly the trickiest, finding the point to start from. So let's take a look at this one. We've got y minus 4 equals 3 and then x minus 2 in parentheses. So just a little bit above that, I'm going to write out the skeleton form of our point slope form. All right, so y minus y1 equals m and then x minus x1. All right, so don't forget that x1 and y1 make up the point, m is the slope. So what I want you to notice here is that when I'm grabbing the x1 and the y1, right, if I take a look at the skeleton, right, the subtraction is already built in. So when I'm looking for y1, it's just 4, right? It's not negative 4, even though it looks like it, right? Because this subtraction is the same subtraction that's built in, right? So it can get a little bit tricky there. So my y1 is just 4. My x1 is just regular old 2, right? For the same reason, right? That subtraction is built in to both parts, right? So when I'm grabbing my point x1, y1, it's just 2, 4, right? A way that, I've seen people, like to think about it is that, imagine that it's lying to you when you're looking at the point. It's trying to tell you the opposite. The x2, or the x looks like -2. The y looks like -4. Don't trust it. Flip them backwards, right? It's +2 and +4. As far as the slope goes, it's just 3, right? And then sometimes it can be helpful if we're doing rise over run to think of it as 3 over 1. Right, so that is something we're going to do here. All right, so let's snag this. Let's bring this on over to the graph, and we'll take a look at how to graph this thing. All right, so my x1, y1 is 2, 4. So I'm just going to go to 2, 4, plot that point down. There we go. After that, my slope is 3 over 1, so I'm going to go up 1, 2, 3 over 1 to get right there. And then all I got to do after that is just connect the points with a line. All right, so let's go ahead and do that. See how well I can do. A little crooked on some parts, but that's okay, right? It's pretty darn close. And that's it. That's all we got to do. All right, so like I mentioned, finding that x1, y1 is really probably the toughest part about this. After that, hopefully it doesn't seem so bad when we pop it on the graph. Let's try another one out. So again, I want to start by finding the x1 and the y1, right? So what I'd like you to do is pause here, see if you got it, right? Don't get tricked. So hopefully you did that, right? Same thing as before. My x1, it looks like it should be -6. I'm not going to trust it. It's +6, right? Because that subtraction is built in. Same thing for the y1, right? It looks like -5, but that subtraction's supposed to be there, so we're going to grab +5. As far as the slope goes, it's just hanging out right there. Our slope is -1 over 3, right? And I know that you might be thinking like, well, this one has the subtraction sign out in front, right? What I would suggest when you're working on slope is just pop it up on the top number, just like I did there, right? Make it -1 over 3. Make your life a little bit easier when we're trying to figure out where to go with rise over run. And so again, let's pop this over to the side, and let's graph it up. So my x1, y1 is 6, 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, right up there. Hopefully I counted right, or else that would be embarrassing. All right, after that, my slope is telling me to go down 1, right? Remember that when you have a negative in your slope, you're going down. So I'm going to go down 1 and over 1, 2, 3 to there. Okay, so after that, again, same old deal. All we're going to do is we're going to connect these points with a line. Hopefully it's not scratching up the microphone too much. Alrighty. Again, a little crooked, but not too bad. Could definitely be worse. All right. So hopefully these don't seem so bad. All right. Let's take a look at another one, which might be a little rough. All right. So again, we're going to graph this point slope form equation. I'm going to write out our skeleton again, just to help us out. All right. So y minus y1 equals m, and then x minus x1 in the parentheses. So on this one, we've got y plus 3. That's kind of weird, isn't it? Well, how about this? Would you agree with me? And I know you can't answer me because we're on the computer. Would you agree that y plus 3 is the same as y minus -3? Right? Isn't that something that we kind of took care of before? And actually, if I kind of put it in a different color, it might even, seem a little more familiar than from what we were doing earlier. So that's really y minus -3. That -3 is what we want to grab for our y1, right? So again, the shortcut way of thinking about it is that the equation is trying to lie to you on the x1 and the y1, right? They're the opposite of what they look like, right? So that's actually going to be like, it looks like +3 next to the y. We're going to grab -3 for that y1. All right, the slope's not doing anything too fancy in the middle there, right? M is just -2. Right. And then over for the x's, right, it's the same kind of idea, right? This is the same thing as x minus -7. Right, so if I wrote it that way, -7 is what I would want to grab for my x1. So when I'm grabbing these 2 points, or this point, x1, y1, the x1 is -7, the y1 is -3. As far as the slope goes, it's -2, which again, we're going to think about as -2 over 1, just to help us out with the rise and run. Yeah, so plop this over here. Ooh, look at that. One movement. Pretty fancy. My starting point is at -7, -3. So that'll be right down over here. All right. After that, my slopes tell me to go down 2, and over 1, right over to there. Right. I know that some of my rise and runs haven't been the best. Right. Let's erase it to hide the evidence. All right. So after that, again, connect them with a line, and then we're good to go. Oops, it's starting to move on me. There we go. Not too bad. All right. So what I'd like you to do, for number 13, try the whole thing on your own, right? Try and find the x1, y1, doing it the same kind of way we did before. Figure out what your slope is, and then see if you can graph it up. And so hopefully you tried that one out, right? It really is good to try these on your own because, again, worst case scenario, you're wrong, right? It's not the end of the world. You just, you try it again. Not too bad. So when I'm grabbing my x1 and my y1 out of this one, all right, we've got the same kind of situation as number 12 right up above it. We don't want to trust what the x1 and y1 look like they're going to be. We want to grab the opposite. So for x1, I'm looking over here. It looks like +3, so instead I'm going to grab -3. Right. For the y1, I'm looking over here. It looks like y +1, so I'm going to grab -1 for y1. Right. So that's our point, all set and done. If you're feeling pretty confident on that piece, then awesome, because that really is the toughest part about graphing point slope. After that, my slope is just hanging out in the middle, -2 over 7. Right. Nothing too fancy going on there. All right, so plop this over next to the graph. So your starting point is -3, -1. So hopefully when you tried it out, you got that point there. After that, my slope is -2 over 7. So I'm going to go down 2. All right, let's try that. And then over 1, 2, 3, 4, 5, 6, 7. Right on over to here. All right, it's a long way for a tiny dot. All right, so after that, all we got to do is we're just going to connect these up with a line, and then we are all set on this one. All right, popping those arrows on the ends because lines go on forever and ever and ever. All right, so hopefully that doesn't seem so bad, right? If you got a little bit off, right, that's okay. What I'm going to tell you is that this last problem, number 14, we're not really going to be focused on the word problems too much. So if you would like to, stop here, that's perfectly fine. If you want to stick around, I am going to talk through it real quick. But, if you are leaving here, be sure to check on Google Classroom for any additional stuff. We'll talk about the practice when I see you all together. All right, we'll practice a little bit more with this graphing. If you are sticking around for number 14, let's talk it through. So we'll say that this is not something we're going to dive deep into or word problems related to these things, right? But, they're kind of interesting to work through. So biologists have found that the number of chirps field crickets make per minute is related to the outdoor temperature. The relationship is very close to being linear, right? So the word linear means that, I can talk about it using these linear equations we're working on. When field crickets chirp 124 times per minute, the temperature is 68 degrees Fahrenheit. When they chirp 172 times per minute, the temperature is 80 degrees Fahrenheit. And so first things first, I'm going to grab some important pieces of information. Right? When field crickets chirp 124 times per minute, the temperature is 68 degrees. When they chirp 172 times per minute, then the temperature is 80 degrees. Right? So the reason I put those in two different colors is because that's two different little bits of information. Right? So what we can do with those bits of information is we can set up 2 points. We can find the slope and we can go from there. Right? So what we're going to do is we are going to set up a way to talk about our points first. So what I'm going to do is I'm going to say that my points are set up like this. They are the number of chirps, comma, temperature related to those chirps. All right, so what we can do now is everything in yellow, right? We had 124 chirps per minute. And then the temperature was 68 degrees. For the stuff in green, it was 172 chirps per minute. The temperature was 80 degrees. All right, so again, stuff in yellow was the first one. Stuff in green gives us the second point. All right. So once we have 2 points, what we're able to do is we're going to set up our slope formula and figure out the slope. Right? We want to find an equation for the line through the points. So just like those problems we were working on earlier, we need to figure out the slope. So we've got m equals, right, do some subtraction on the top and bottom, and then we'll do y2 minus y1, right? And here what I'm going to do is I'm going to call this top point, this is the x1, y1. Call that second point the x2, y2. All right, so we're going to have y2 minus y1 up on the top. We're going to have x2 minus x1 down on the bottom. All right, we'll go ahead and simplify that. 80 minus 68 leaves us with 12. 172 minus 124 leaves us with 48. 12 over 48 is the same thing as 1/4 if we simplified it down. Right, so this is what our slope is going to be. Right, so after that, we have our slope. All I need to do is plug it into, a point slope equation. So, I'm going to put out my skeleton, y minus, got an equal sign, and then in parentheses I'll have x minus something else. Right, and you can choose either the x1, y1 or the x2, y2. Right, I'm going to choose to work with the x1, y1 because the numbers are a little bit smaller, right? That's really the only reason. So y minus y1 equals the m, that slope we just found, and then x minus x1 in the parentheses. All right, if you did want to use the other one, I'm going to write that out. Right, it's y minus y2 equals m, which is our slope, and then we'll have x minus x1, or x2 in this case. Excuse me. All right, so either one of those would be fine. I'm going to use that one up top just because the numbers are smaller, right? Might make things a little bit easier. So what we want to do now is we want to figure out what is the temperature if the crickets are chirping 150 times per minute. All right, so we've got these equations, and we know one of the values is 150 chirps. So the tricky part here is to figure out where to put that 150. So what we're going to do is take a look back at how we set up our points, right? They're chirps, comma, temperature. Well, the chirps is in the x part. The temperature is in the y part of the point, right? So when we're trying to figure out what is the temperature, right, that means that y is the one we don't know. We don't know the temperature yet. If they're chirping 150 times per minute, then that means that my x is 150, right? So what I'm going to do is I'm going to take one of our equations. I'm going to, again, use the one with the 68 and the 124. All right, just going to rewrite it real quick. And then what we're going to do is we know that x is equal to 150. I'm going to plug 150 in where I had x. And we're going to solve for y. All right, so again, instead of x, I know that x is 150, right? That's the chirps per minute. Right? And then we're all set up to go, right? From here, we're going to go through a couple steps of simplifying this, right? So we're going to still have y minus 68 equals 1/4. We're going to take care of what's in the parentheses first, right? Remember your order of operations. So we end up with 26 left over in there, right? After that, doing that multiplication that's hanging out over on the right-hand side, 1/4 times 26 is going to give us 6.5, right? And last but not least, to get that y by itself, what I'm going to need to do is add 68 to both sides. All right, so 6.5 plus 68 more is going to give us 74.5. All right, so that is our y. And remember that y was talking about temperature up there. Right, so what we can do is we can put degrees Fahrenheit on that, and we are good to go. Right, so 150 chirps, if you hear them outside, means that the temperature's a nice moderate 74.5 degrees, more or less. Not too bad. Right, so again, be sure to check on Google Classroom for any additional stuff. We'll work on the practice problems when I see you in person, and if you have questions, you can email me, you can ask in person when I see you, but please ask questions if you're not sure about something. And I will see you next time. Bye.